Okay, hello 1018. We're going to have a look at two things today. We're going to have a look at the concept of free fall, when an object is falling under constant gravity or a constant gravitational field strength. And we are also going to look at an equation that you can only use if acceleration isn't changing. That means it's constant and it's one number. So something to think about. You can pause the video to do this, but a glass marble and a grand piano are dropped off a school with a height of 6 meters. Which object accelerates the most and why? So do you think the marble hits the ground first? If my marble here, I can kind of see where the mouse pointer is, or do you think the piano would hit first? Just pause the video and write down your answer. So hopefully you've written down your answer as to if you think the marble or the grand piano hits the ground first. The actual answer to this is if you ignore air resistance, both of them would hit the ground at the same time. They would have exactly equal acceleration. So what we're doing now is we're going to hopefully teach you so you'll be able to recall the acceleration due to gravity at the surface of the Earth is constant. And it's actually 9.81 meters per second. And we're going to show you an equation, v squared minus u squared equals 2as. We're going to go through that equation that you can only use if a, which means acceleration, is constant. And I must stress, if acceleration is changing, you cannot use this equation. And that's probably where we'll leave it. Okay, we're going to leave the stage by stage breakdown of maybe a parachute is falling through the atmosphere to another video. Okay, I just think that'll be too much if we do it all at once. So the answer to the question, really the piano and the marble would hit the ground at the same time. They do that because the acceleration due to gravity is the same for both of them. They both accelerate at 9.8 meters per second squared if you ignore air resistance. So the gravitational field strength, or the acceleration due to gravity, two words for the same thing, the acceleration, is 9.8 meters per second squared at the surface of the Earth. So this is a bit weird, really, because I imagine that for quite a few of you, you would have thought clearly, well, the grand piano is going to hit first because it's more massive. So Galileo, who was a scientist many hundreds of years ago, first came up with an experiment to test this. And he said, well, if you could drop a hammer and a feather from the same height at the same time, they'd both hit the ground first if you ignore air resistance. And that's really quite difficult to test, actually, on the surface of the Earth, because there's air everywhere. So if you go to this link here, and maybe I'll put that in the description so you can click on it easier, we've actually devised a way to test this on the surface of the Earth. And I just check that this video is, yeah, so this is the video that I want you to watch. So watch it and convince yourself that if air resistance is ignored, that they both fall at the same rate because the acceleration due to gravity on the surface of the Earth is a constant. And in fact, we have an equation that we can use on every occasion where acceleration due to gravity or otherwise doesn't change. And that's this equation. Please do write it down. V squared minus u squared is equal to 2 times a times s, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement, so the distance in a direction that's known, that's been moved. And if you're using displacement in meters and both your velocities in meters per second, then the acceleration will be in meters per second squared, m/s squared. So please pause this video and please make a note of this slide. Right, you have to learn this, and it's the hardest equation. It has the most terms in of all the ones that you need to know for your GCSE in physics. So we are going to go over the steps of how to answer questions based on this equation. So you will always be asked to find one thing in that equation, one quantity that you don't know, and you will always be given the information for all of the other quantities. So let's go through an example now. So a car decelerates uniformly from a speed of 10 meters per second to a speed of 4 meters per second in 20 meters due to a squirrel running out in the road. Calculate the acceleration of the car. So your first step is always to write down the information you know and highlight the thing that you need to find out from the question. So the first thing we're told is that the acceleration is uniform. That means it's one number, and so it's really a strong hint that we can use this v squared minus u squared equals 2as equation. And it says from a speed of 10 meters per second. So that's telling us that the initial speed is 10 meters per second to a speed of 4 meters per second. So that's telling us that the final velocity is 4 meters per second. So that's our v. I must stress here, it's implied here that you know the direction that the car is moving. You know, it's moving forward, and that in that case it's okay to change a speed to a velocity. But really, being strict, the question would make it clear either through the diagrams or through the instructions which way the car is moving, because speed and velocity aren't strictly the same thing, as you should know by now. And it says it's moved 20 meters, so that's our s, our displacement, and it's asking us to find out the acceleration. So you can see in the blue box I've consolidated all the information that it's telling me. The second stage is to write down the formula. So v squared minus u squared equals 2as. Just write it down. We are going to have to manipulate this formula to get to our answer. The third step is always to rearrange the equation to get the thing that we want as the subject of the equation. So our challenge is to rearrange the v squared minus u squared equals 2as equation so that acceleration is the subject. And 2 times a times s is over the right hand side of this equation. So to get s on its own, you have to divide, to get a on its own, you have to divide both sides by 2s. And then your equation turns into a equals v squared minus u squared divided by 2as. So if you're not confident in rearranging equations, it's really important that you admit that, and it's not a problem, you've still got time on your side, and that you go away and you learn the rules. Alright, so a key thing here, and I'll do it for you, 2as means 2 times a times s, and because multiplication is commutative, I can write down 2sa, because it doesn't matter what order you do multiplication in. So then I hope you see, if I take and give myself some space over there, if I divide both sides by 2s, and I'm allowed to do that as long as I do the same to both sides, I'll just put a little underline on that one so it represents divides. Then on the right hand side of the equation I've got 2s on the top and 2s on the bottom, and if you divide something by themselves you get 1, and if you times a by 1 you can ignore it. So the whole thing, the two s expressions on the right hand side and the denominator and numerator will cancel, and so that's how you get a is equal to v squared minus u squared over 2as. The next stage is to put your numbers in. So you know v is 4, and you know u is 10, and you know s is 20. So you put the numbers in, and that gives you this expression here. So I'll make that a bit bigger. And the next stage is to use BODMAS. Sometimes it's called BIDMAS. So we have to do the calculations in order. So here I would do the brackets first, which would give me 40. Then I would do in the denominator. Then 4 squared is 16. 10 squared is 100. So I get 16 minus 100 divided by 40. And if I do that, I get 2.1 meters per second. And it is negative. So I definitely need that, because acceleration is the change in velocity. And if you have a change in velocity, you're dealing with a vector. So if you're dealing with a vector to make acceleration, then acceleration itself must be a vector. So why do you think the negative answer makes sense here? Well, a positive acceleration in this case would represent getting faster, so a negative acceleration would represent getting slower. So I'd like you to ignore the extension here, because I just want to make sure that you get the basics in this video. I would like you to pause the video and try and use that strategy to answer questions 2, 3 and 4. So extracting the information, writing down the formula, rearranging it, putting the numbers in and getting an answer with a unit. It should take you probably 10 to 15 minutes, so have a go. Okay, so hopefully you've tried that. Let's go on to the answers. So a plane accelerates from rest with a constant acceleration of 20 meters per second squared in a displacement of 100 meters. What velocity will it reach? So step 1 was to extract the information from the question. U was 0, A was 20 meters per second, S was 100 meters, and V we are looking for. Step 3, put down the formula, which I've done. And step 4, rearrange it. So we're after V here, or after this expression. So the first stage of getting it on its own is moving that u squared to the other side. So you have to do the opposite function on both sides. So the opposite to minus u squared is plus u squared. So if you add u squared to both sides, the u squareds cancel out on the left hand side of the equation, and your right hand side becomes 2as plus u squared. Now that would be okay if we wanted v squared, but we don't, we want v. So to go from v squared to v, we have to square root. So I've square rooted my left hand side going from this stage to this stage, which means that I have to do the same on the right hand side. And I've used brackets just to keep my my 2as and my u plus u squared together, because I'm square rooting the whole side. So then I put my numbers in, and it gets really easy actually, because u squared, u is 0, so u squared will be 0. So actually I've got the square root of 2 times 20 times 100, which is the square root of 400, which gives me 20 meters per second. Another thing to note, I struggled a bit with this video, but if I was handwriting this, I'd make sure that the equal signs would be underneath each other. So I'm showing the examiner step by step my thinking. So off to 3 then. A bullet train, which is a type of a fast train they have in Japan, accelerates uniformly at 0.5 meters per second squared for a displacement of 200 meters and reaches a velocity of 220 meters per second. What is the initial velocity? So step 1, pull out your information from your question. U is question mark, A is 0.5 meters per second squared, S is equal to 200 meters, and V is 220 meters squared. Good. Step 3, always write down your equation. And in this case, we need to get U on its own. So we need to move this V squared term, and if the sign isn't there in front of it, that means it's always a plus V squared. So you have to do the opposite to plus V squared, which is minus V squared to both sides. So if you do that, the V squared disappears from the left hand side here and reappears on the other side as minus V squared. But you have to be careful, U squared is still minus U squared because this minus sign here hasn't been altered. So how do you get rid of this minus sign? Well, the best way to do that is to times both sides by -1. So I'm just going to put a times -1, or maybe I can write it like this. So I times -1 on both sides. Well, why have I done that? Well, if you times the left hand side by -1, you have to do the same to the right hand side. But all of that really does, anything times by 1 is itself, and the minus sign will just swap the positive to a negative. So I'll get rid of that now because I've done that function. So what that's done for me is it's got rid of this minus here, and I do apologize actually, I just want to clarify that. So I've times by -1 on this line, excuse me. So I've times by -1 on that side, so that minus there has disappeared, and what has happened is that all of this side here, so I've put it all in brackets to keep it together, has got to have a minus in front of it. So a good trick that, so if you want to change a positive to a negative or a negative to a positive, just times both sides by -1. Then you put your numbers in. So A was 0.5, S was 200, and V was 220. Working inside the bracket first, I worked that out. I put it in my calculator. 2 times 0.5 is 1, so I can ignore it. And then 200 minus 220 squared actually gave me minus 48,200. And that's all in brackets with a minus in front of it. Now, here I've got a minus of a minus. So when you times a minus by a minus, you get back to a positive. So that just cancels out, and I get U squared is equal to 48,200. And I don't want U squared, I want U, so I have to square root both sides. So the square root of U squared is U, and the square root of 48,200 is root 48,200. And when I put that into my calculator, I got 219.3 meters per second, and I've rounded that to the nearest meter per second as 219. Probably as hard as it gets that question. So again, I tried to keep my my equal signs underneath each other. Could probably do it a bit better. So and that stuff was just the information in the question. So please correct yourself using that one. And finally, the last one. So how far will a human travel to increase their velocity from 4 meters per second to 8 meters per second with a uniform acceleration to 0.32 meters per second squared? So please note, in the question again, you're getting the word uniform. In the last question, you had uniformly. You might see constant. And whenever you're told that the change in velocity is constant or the acceleration is constant or uniform is really a massive hint in this course that they are asking you to use v squared minus u squared is equal to 2as. Step 1, extract the information from the question. So I have u is equal to 4 meters per second squared, v equals 8 meters per second squared, and the uniform acceleration as 0.32 meters per second squared. And apologies, I've made a mistake there. That u should not have a square by it. It's a velocity and not an acceleration, so it should be measured in meters per second. Put down my formula again, and now I want to rearrange for s. And hopefully you can see here, to go from this equation 2as on the right hand side to just having s on the right hand side, you need to divide both sides by 2a. And let's just show you that explicitly. So if I divide both sides by 2a, you see that you have 2a on the top and 2a on the bottom. And what you can do is cancel the 2a. So you end up having s is equal to v squared minus u squared divided by 2a, which is this line here. Put your numbers in. V is 8, u is 4, and a is 0.32. So if you did that step by step, actually you would end up with 64 minus 16 over 2 times 0.32. So if you put that into your calculator, and you've got to be careful to do Bob math, so brackets, order, division. So actually you need to do the fraction first, so we can do that together. 64 minus 16 is 48 on the top, divided by 2 times 0.32, which is 0.64. So 48 divided by 0.64. Does that really give me 7.5? So I'm not convinced that that does. So let's do that. Okay, the mistake there is a very easy one to notice. So I looked at my answer and thought that it seemed too small. And yeah, I made a problem with the decimal point. I had 7.5 and I was being sloppy, and it should be 75 meters. So that's really a warning sign to you guys that if you don't check your calculations after doing them, or carefully as you're doing them, and think, is that number too big, or that seems too small, and you blindly just like accept what's written, then maybe you've slipped up, maybe you've read off the calculator wrong. Alright, so you need to be thinking, is my answer sensible at every stage? So a bit of reassurance. Not an easy lesson. It's probably the hardest lesson in this forces unit so far, and mathematically it doesn't get any harder than this. So this is kind of like your harder questions in the exam. They're difficult, they don't come up that often, but if you're able to do them and other students aren't, then you'll be outperforming them. Okay, thank you very much, and next time we're going to do some work on free fall stage by stage.